We'll be starting the session in approximately another 2 minutes. Just admitting all the people. I think most of them have joined. Thank you, guys. Thank you so much for taking the time out on a Sunday evening to join the session. I'll start off with a very short, brief video on an introduction about Apna Xclusives. I hope you can see my screen as well.
वेलकम टू अपना कम्युनिटी। ये वो जगह है जहां आप अपने असली पोटेंशियल को एक्सप्लोर कर सकते हैं। देखो, सबके पास स्किल्स होते हैं, पर क्या आपके अंदर वो स्पार्क है जो आपको कामयाबी की ऊंचाइयों तक ले जा सकता है? अगर आप सोच रहे हैं जॉब चेंज करने के लिए लेकिन रेज्यूमे सेलेक्ट नहीं हो रहा, या फिर इंग्लिश में इंटरव्यू देना थोड़ा चैलेंजिंग लग रहा है, तो फिक्र मत कीजिए, यहाँ हम हैं आपके साथ, आपको सपोर्ट करने के लिए। अपना कम्युनिटी में आपको मिलेगी बेहतरीन कम्युनिटीज जहां आप अपने प्रोफेशनल स्किल्स को सुधार सकते हैं। चाहे आप एक्सेल, टैली, जीएसटी में माहिर बनना चाहें, या फिर आप खुद एक ब्यूटिशियन या डिजाइनर हैं, तो यहाँ आप अपने काम को शोकेस करके दूसरों को टिप्स एंड ट्रिक्स देते हुए आगे बढ़ सकते हैं। अपना कम्युनिटी में आपको मिलेगा मेंटर्स का एक खजाना और बड़े इन्फ्लुएंसर्स का साथ, जो आपको हर कदम पर 1-to-1 गाइड करेंगे। यहाँ आप ज्वाइन कर सकते हैं अपने फील्ड या इंडस्ट्री स्पेसिफिक ग्रुप्स, जहां आपको ऐसे कई लोग मिलेंगे जिनसे सीख के आप वो गलती ना करें जो वो कर चुके हैं। ऐसे लोगों की जिन्होंने स्टार्ट किया था एज एग्जीक्यूटिव्स एंड आर नाउ सक्सेसफुल मैनेजर्स इन देयर डोमेन्स, जो आपको आगे बढ़ाने में मदद करेगा। यहाँ आपको मिलेगा वो सही डायरेक्शन जो आपके करियर को नेक्स्ट लेवल ले जाएगा। तो लेट्स अनलॉक योर पोटेंशियल टुगेदर। अपना कम्युनिटी में ज्वाइन करें और अपने सपनों की ऊंचाइयों तक पहुंचने का सफर शुरू करें।
Awesome. Thank you guys. Thank you for joining again. I hope everyone joined. There's no one in the waiting room. Right, no one. Thank you guys. So welcome everyone again. As a part of community engagements with Apna, we have been conducting these Apna exclusive sessions every day, weekdays at 7 p.m. and weekends at 3 p.m. and 6 p.m. The main idea being to help people ideate and advance in their professional careers. We are covering a wide range of topics here. It can be as simple as spoken English or financials or accounting, and also be technology like product and data science. And myself, Rohan from QFers. QFers is a mentor aggregator platform. And we have a great mentor here, Mary, who's been associated with QFers and Apna for quite some time now. Mary is a data scientist at Cisco, and he's been with Cisco for quite some time, mainly into data science, insights, CX operations, and analytics team. And Mary has completed his MS in data science, MS in machine learning, and completed his BTech in computer science. So without much overdue, I will hand it over to Mary. You can just give a very short intro on you. We can go get on to the session. And guys, I'll be also taking all the questions on the chat box. We'll try to have about a 15-20 minute session, have a couple of questions, and then 15-20 minute session, and close the session with the question and answers. Hope that's fine. Thank you, guys.
Thank you, Rohan. I'll just take it from here. Let me just share my screen. Let me know when you can see my screen.
Yeah, it's visible.
Yeah, great. So, hi everyone. Good evening. So, myself, Marimal George. I'll just take you through something called as a structured data and SQL. I promise you that it won't be much technical, but then I'll give you the crux of it. You'll get to understand what is structured data, why is it important, and how do we analyze it, so that you get a flavor of how the industry is working with the new technology in data science and all these set of data that is there. Before that, I'll just take you through the agenda. So first few minutes, I'll give an introduction about me. Then we'll try to understand what data and analytics is. I'll introduce you to RDBMS and SQL. Then a few of the functionalities that is there in SQL. And then I'll try to give you a gist about what is data science, what is AI and ML, and then where does Python and SQL sit, and what are the important things that you have to take care while you are working on a data science project. And then after that, since we only have very limited time of 45 minutes, what are the next steps that you can do so that you can enrich yourself with the knowledge that you can take further to the advanced level of data science. And then towards the end, we'll have 15 to 20 minutes for question answers, where I can answer your queries or questions that you have regarding the topic, the content, as well as any of the general industry questions. Okay. So myself, Mehmet George, and again, if you're confused about how to address me, you can call me as Mary. I am a senior data scientist with 11 years of experience in data analytics field that spans across different technologies like data warehouse, big data analytics, data science, machine learning, and artificial intelligence. And I initially started my career with Nielsen, and then I moved to IBM as a senior technical specialist, and now I am working as a senior data scientist with Cisco. And I've, as already Rohan mentioned, I've completed my master's in data science, and I have submitted my thesis paper in MS and machine learning and AI. So that's pretty much about my career as well as my educational background. I've been working in this data analytics field for the past 11 years. Okay, so with that, let's get started with the content for the day. Okay, so everyone knows what data is, but let me try to understand what your understanding about data is. Does anyone know? Explain. Can you give me a definition about what data is? Anyone in the chat or anything would be fine. Anyone? What data is? What is data? Data is information. Anything else? Everything is data. Raw information. Raw facts and figures. Prashant, good answer. Okay, so let's get started. Okay, I'll give you, so few of the, one of the answer is exactly the definition for data. Data is nothing but raw facts and figures. Okay, what does it consist of? It could be any observations, it could be any perceptions, it could be numbers, characters, symbols, or images, audio, video. Anything that falls in this category, which is raw, is what is called as data. So then what is information? Data is not information actually. Okay, when you process the data, you get information out of it. Now let's try to understand that with an example. So I saw a couple of responses which said that data is information. No, data and information are two different things. Data is nothing but raw facts, figures, etc. And when you process that data, that's where you get information out of it. Let's try to understand what this means through an example. Okay, I've put two things here: SK01B3413, NL07K96. Can anyone guess what this would be? What this is? Anyone? In the chat? Anyone? No, you are not able to extract, right? So this is serial number. Anything else? What kind of serial number? That's what. This is raw thing that I've given you. This is data. Now I'm going to tell you how to process this data so that you can extract information out of it. Okay, so let's see. SK stands for Sikkim. 01 stands for Gangtok. B stands for 19,998 vehicle. And then 23,411th vehicle is what? You see this. This is nothing but your number plate. Okay, that you see in your cars, right? In your vehicles, it stands for the number plate. So SK stands for Sikkim, 01 stands for Gangtok, B stands for the letter which says that all 19,998 vehicles have been already registered. And then this is the 3,413th vehicle after the 19,998 vehicle, which means that this vehicle is the 23,411th vehicle. Now you know how to process this data, correct? I told you how to process it. And so now you are able to extract the information out of it. And so this one becomes easy for you, right? NL07K96, you know that it is nothing but the vehicle registered in Nagaland, right? Very simple. So what I'm trying to tell here is when I gave you SK01D3413 or NL07K96, you didn't understand it. Why? Because it was nothing but raw fact and figures. It was just observations, it was facts, it was numbers, characters. The moment you understood how to process it, you processed it and you got the information that, oh, okay, SK01B3413 stands for the 23,411th vehicle registered in Gangtok RTO of Sikkim. Similarly, in the same methodology, you figured out that this is nothing but another vehicle, which is this, which is 1,28,084th vehicle registered in Dimapur RTO of Nagaland. So this is the difference between data and information. So from now on, if someone asks you what is data, let's not tell the answer as data is information. Okay. The moment you process data, that is when you get information out of it. Data, as it is it's in its raw form, has only facts, figures, and numbers. The moment you process it, you get information out of it. All good with this? Let's move to next thing. Now you understood that there is something called as data, and when you process it, you get information out of it. Now there are different types of data. On the basis of the structure, data can be categorized into three. First one is called as the unstructured data. Second one is called as the semi-structured data. And last one is called as the structured data. Now let's try to understand what each of these category means. Okay. Unstructured data. It does not contain any field, columns, or it doesn't have any structure at all. Okay. It doesn't follow any particular format, sequence, semantics, or rules. Okay. And it doesn't have any predefined data model. Source of unstructured data could include your multimedia files like audio, video, etc., your social media data, docs, and PDFs. Now, let me give you an example so that you can understand more about what unstructured data is. Let's take a PDF document that you have in front of you. Your first paragraph might contain 10 sentences. Doesn't mean that your second paragraph also contains 10 sentences, right? Your second paragraph may contain 5 sentences. It may contain 15 sentences. Your first line may contain 20 words. Doesn't mean that your second line also has 20 words. It could be 30 words. It could be 15 words. Your third sentence may have more words, etc. Which basically means that a PDF document, you can't write any rule telling that the first paragraph will contain 10 sentences. Every paragraph has 10 sentences. Every sentence has 10 words. There is no defined rule. There is no structure at all. Your first paragraph may have n number of sentences. Your second paragraph may have n+1 or n-1 or any number. So if there is no format, if there is no structure, if there is no predefined rules for data, it is called as unstructured data. And simple example is your PDF file, your Word documents, etc. There is no definite structure to it. It could be in any way. It could be random. It could be any number of sentences extra. Then it becomes unstructured data. Now comes the second type, which is your semi-structured data. It has some organizational properties, but lacks a fixed or rigid schema. It cannot be stored in the form of rows and columns, but contains tag or other markers to separate semantic elements. Some of the examples of semi-structured data are emails, XML files, and JSON files. Let me give you an example and then you will understand. When you receive an email, you always know that there is a header to it. There is a topic to it. Then you know that who is the sender, correct? Then you know that who is it addressed to it. You know who are there in the CC. Then you know that the email has a body, right? So the body can contain any number of sentences, correct? So is there a structure? Yes. What are how do you define the structure? There are tags. The tag to tell me to whom the mail was sent. The tag from tells me from where it has come. But you can't tell that the mail address should contain only 10 characters. The mail address can have 10 characters, 20 characters. Then comes the body of the mail. The body of the mail can have 10 sentences or 20 sentences or 30 sentences, but you know that there is a body to the mail. So that is why it is called as semi-structured. Is there a structure? Yes, it is structured. Is there a complete structure? No. You know that there is a body, there is a to, there is a from, etc. But inside that to, from, or body, the structure may change. The structure need not be consistent. You take two mails. Both the mails will have a to and from, but the to and from or the body can have different content with it, different number of paragraphs in it. That is why it is called as semi-structured. Very simple. Unstructured, no rules, no structure, no tags. When you come to semi-structured, there is a structure, but it's not rigid or it's not consistent across all the emails. All good? Then comes the last one, which is your structured data. It has a well-defined structure. You know that it comes as in your rows and columns. That is what is called as the structured data. Example are SQL DBs, your online transactions. Simple examples are your spreadsheets or Excel sheets. When you see Excel sheets, you know that there is a first column. If it is a roll number, you will only see roll numbers in it. Then there is a second column, which is a name. You will know that it will be name of the participants. There is a strict format to it. There is a strict structure to it. I can give this Excel sheet to someone and tell that, hey, your second column corresponds to this. And so all the values in your second column will have that particular value in it. That is why there is a defined rigid structure. It will not change. And that is why it is called as structured data. So three types of data. It starts from unstructured data where you do not have any kind of structure. Then semi-structured. There is some structure, but not completely. And then comes the structured data where you have defined structure. All with me? Any questions till now?
I think we can take a couple. In the
Yes.
beginning, there was one, is it possible to get into data field with just skills and not having a degree?
So any kind of industry or domain related question we'll take to the end. We'll try to stick to the content for the time being. All these questions are kind of generic and we'll take that in the end, if that is fine.
That's fine.
Yeah. Any content related question right now?
Not really. I think we can continue.
Super. Okay.
Yes,
Next.
sir. Sir,
Yes.
sir.
Yes.
Sir, this structured data is a similar structured data or only structured data?
Sorry, I didn't get that. The structured data is?
Is this a similar structured data or only structured data, sir? It means it has any changes or any.
No, so when you get an Excel sheet, it will have always rows and columns, correct? That structure is never going to change. So if there is a predefined scheme or if there is a predefined structure telling that everything is a row and a column, then that is structured data. Did I answer your question? Or?
Yes, sir. Yes, sir.
Okay, it will always have, so any Excel sheet you take. So if I send you an Excel sheet, your friend sends you an Excel sheet, your professor sends you an Excel sheet, everything when you open, you will see rows and columns, correct? It has that structure. So it is called structured data. I send you an email, someone sends you an email, every email has to address, from address, and what is there in that email. But the content of the email will be different. I send you an email telling that welcome to the session. Your friend might send you an email which has a YouTube link and all those details. Your professor might send you an email where the body will have the details about the session, etc. The content is different, but there is a certain structure, which means that it is half structured, half unstructured. That is why we call it as semi-structured. Okay. Now, I send you a Word document. Someone else sends you a Word document. You took my Word document. My first paragraph has 20 sentences, but your friend's first paragraph has only 5 sentences. So there is no structure at all. There is no consistency across. That is what is called as unstructured data. Okay. So structured data, always rows and format. Semi-structured, half structured and half unstructured. Unstructured, completely no form, no rules at all. Okay. All right. Moving on. Next one is, let's try to understand what data analytics is. Okay. When you analyze your business data using certain statistics and software, you figure out insights and patterns out of it. This will help you to make better decisions. This entire process is called as data analytics. Okay, I'll give you a simple example to understand that. Okay, let's say that you are traveling from source A to source B. Okay, now on the first day you took route A, which took 1 hour to reach and costed you 100 rupees. Okay, on the second day you took another route which took you to destination B only in 45 minutes, but it costed you 150 rupees. Now, on the third day, which route will you take? Will you take the first route or will you take the second route? What do you think? On the first day, I took a route which took me 1 hour to reach my destination and it costed me 100 rupees. On the second day, I took another route. First route, route A. Second route, route B. Second day, route B took me 45 minutes and it costed me 150 rupees. So on third day, which route will I take?
Second route.
Why is that? I never told that I want to reach early.
Yes,
What if my demand is to reach with lesser cost, right? So that is where your analytics comes into picture, and that is why this better decision makes sense here. I'll tell you, if some scenario like this comes, the first question that you have to ask is, what should I optimize? Are you looking to reach with lesser cost or are you looking to reach early? Based on that, you take the decision, right? Both decisions that you take, okay, on the third day, I can go in route A, that is also a decision. I can go in route B, that is also a decision. But for my outcome, which is the better decision? I want to reach as early as possible. Then I will take route B. I want to reach in such a way that I save money. Then route A is the better decision. So basically, what did we do here? We went back, analyzed our data, and we figured out that if I use route A, I'll save some money. If I use route B, I'll save time. How did I analyze? I can use different softwares or statistical methods to analyze that. And based on that, I found out the insight, which is information, which is route A, less money, route B, less time. And then based on what the business is demanding, if the question is, how can I reach early? The better decision is to go in route B. Route A, I can go in route A. That is also my decision, but is it a better decision for the outcome? No, the better decision is to go in route B. So when you analyze your data using statistics and software, and you find insights and patterns to make better decision, then this entire process is called as data analytics. All good with me? So think this better decision is an important word. People usually miss that, okay? You use all these things and then you help the business to make better decisions. This entire process is theoretically called as data analytics. Now, moving on. Does anyone know what are the different types of analytics? Anyone? Anyone? What are the different types of analytics? I'm pretty sure that you know one of them. Everyone knows one type of analytics for sure. No one? There are, okay, let me go. There are basically 4 types of analytics, which is descriptive analytics, diagnostic analytics, predictive analytics. Everyone might have heard about predictive analytics, right? And the last one is prescriptive analytics. Now, what is descriptive analytics? Descriptive analytics basically tells you what happened. You look into the data and you know what happened. You understand what are the things that have happened historically. That is what descriptive analytics is. Diagnostic analytics is you are trying to figure out why these things happened. So first you look into the data, you understand what happened. Then you try to understand why it happened. Third one is predictive analytics, which is you're trying to guess what is going to happen. Okay, what is going to happen in the near future? I'm trying to forecast or predict what is going to happen. And the last one is the prescriptive analytics, which basically tells you what should be done for this future. for the coming future. Now, you will have a confusion. Now, the one thing that you have to remember here is this has to happen in an order, which means that you can do diagnostic analytics only after you do descriptive analytics. You can do predictive analytics only after you do diagnostic analytics, which in turn can be done only after you do descriptive analytics. Last one, obviously, again, prescriptive. You can do only prescriptive after you do predictive, which in turn can be done only after you do diagnostic, which in turn can be done only after you do descriptive. Okay, now I'll give you a small anecdote to remember this. Okay, imagine that you have fallen ill, you are sick. Okay, and you are visiting a doctor. What is the first thing that you do? You describe to the doctor what happened to you. You are giving a description of what you are going through, right? Then what will the doctor do? He will try to diagnose it, what happened. Then he will try to tell you, in the coming days, your temperature might go up, you will have more cough, etc. He's trying to predict what is going to happen. And the moment you are going to leave the room, he's going to give you a prescription telling that this is what you should do to avoid this or avoid that. So descriptive, what happened? Diagnostic, why it happened? Predictive, what will happen? Prescriptive, what should be done? Okay, imagine yourself going to a doctor, very easy. Okay, first thing, okay, I gave a description, so it's descriptive analytics. Then he diagnosed me, so that is diagnostic. Then he predicted what is going to happen, so that is predictive analytics. And then he gave me the prescription, prescriptive analytics. This is the order. I did a descriptive analytics, followed by a diagnostic analytics, followed by predictive analytics, and last one is the prescriptive analytics. Okay, easy to remember. 4 things: descriptive, diagnostic, predictive, and prescriptive. It has to be in the order. Okay, descriptive says what happened, diagnostic says why it happened, predictive says what will happen, and prescriptive says what should be done. Okay, now, usually I've seen people telling that prescriptive analytics is nothing but what should we do to avoid. No, it's never the scenario, right? Let's say that you predicted that the way the business is going, you are going to get more profit, then you won't do anything to avoid it, right? You will try to nurture it. So if the predictive analytics says that the way it is going, the business is going to a loss, then you will try to avoid it. So based on what comes out of predictive analytics, you will either try to boost it or try to lower it down. So better to tell that prescriptive analytics is nothing but what should be done. Okay, so data analytics. So till now what we have learned is what is data, what are the different types of data, what is data analytics, and what are the 4 types of analytics. Okay, let's move to next slide then. Now, in your data analytics ecosystem, what you see is you have a data repository. Repository is nothing but a place where you store your data. It could be a laptop, it could be a database, it could be a data lake, whatever that you hear out, right? It could be a simple hard disk also. Anything or any place where you store the data is called as a data repository. From there, you take the data and you process it. And that entire step is called as the data processing step. Then from there, you process the data and then you try to figure out patterns, insights, information, etc., so that you can make decisions out of it. And this entire process is called as data analytics. And last, after your initial data analytics, you try to do this data science step, artificial intelligence, your business decisions, etc. And you try to give it to your chief CTOs or CXOs. It could be a CEO, it could be a CTO, anyone. You try to convert it into business terms. You go to a CEO and tell that, you just give me a second, 1 second. Sorry. Okay, sorry for that. So you have your data in a repository. From there, you process the data, then you analyze it, you do all these data science techniques, you predict it, and then you convert it into a business term and business wordings that becomes the entire data analytics ecosystem. See, you can't, let's say, I'll give you an example. Okay. Yeah, one of the method that we use in data science is called as hypothesis testing. It's a bit technical term. I know few of them might not know what it is, but few of them might know. I'll give you a simple example. Hypothesis testing is a statistical method where you try to check if something is correct or no. Say, for example, the presence of a sales guy improves my sales is a hypothesis, right? This is what we think. If there is a salesperson, my company's sales would increase. Now, I can put it to test whether it's right or wrong. If a salesperson is there, is my sales increasing or not? That testing is called as hypothesis testing. Now, I can't go to a CEO and tell that, hey, my hypothesis testing, when I did Kruskal-Wallis test, it tells me that the p-value is less, hence I am rejecting the null hypothesis. I'm pretty sure that most of you didn't understand what I told you, right? This is what is data science terms are. Now, converting it into a business term, it means that nothing but if there is a salesperson, when I did the statistical test, looking into the numbers, what my data scientist figured is, if there is a salesperson, the sales is increasing. When I told you this, you understood, right? This is what this conversion of statistical terms or everything into business terms means. Okay. Now, let's understand which are the personas that are there in this scene. So a person who gets your data into your data repository, makes it ready for data processing is the data engineer guy. From there, the guy who takes it, process it and do the initial level of analysis is the data analyst guy. Then this analyzed data or clean data or all those data that is in the format for doing all the data science project is consumed by the data scientist. Once the results out of the data science hypothesis testing and all those comes out, the person who converts it into business term is called as the business analyst. Okay, so data repository, data engineer takes care of it, data processing, data analyst takes care of it, data science and all those analytic techniques, data scientist takes care of it. Once when it is done, when it gets converted into monetary or business acumen, that's done by business analyst. This is your entire data analytics ecosystem. Moving on, I'll take a pause here because we are moving into a new topic altogether, which is relational database. So till now, we learned about data, different types of data, and then we learned about what data analytics is, what are the different 4 types of data analytics, and then we try to understand the entire ecosystem. Any questions, any doubts? Great, I don't see any questions in the chart. Can you please repeat the last part of the slide? Yes, Prashant. So very simple. When you have your data in some hard disk or RDBMS or a data store or a data lake, that is what is called as the data repository, the place where you store your data repository. From that, you consume the data and process it. It's called as data processing. From there, your process data is used for different types of analytics. It could be descriptive, it could be diagnostic, it could be predictive, it could be prescriptive. All those steps is done your analytics step. And from there, converting that analytics result into business terms is called as the business analysis step. Okay. The data part is taken care by data engineer. The processing part is taken care by data analyst. The hypothesis testing and all those data science related things are taken care by data scientists. Conversion of the output of data science projects into business terms is done by business analyst. About the data repository, Meghna, did I answer your question there?
Meghna, you can unmute and you can just request for any answers or questions. Great. Okay. So let's continue.
So when the topic is on structured data and SQL. Okay. See, there is no point in I directly taking you to structured data and SQL without giving a context of what all these things are, right? Why is this important? What is data? You should know. I always feel that there should be a flow, there should be a backstory, then only you will understand why all this is happening. Now we know that what is data, what is information, what is analytics. And in data, there are different types of data. And one of this is structured data. And we have to analyze the structured data because all your business, most of your business happens in a structured format. You go to a bank, right? It will all be in rows and columns. You get some data. Most of them are in Excel format. So all these are structured data, correct? How do you analyze the structured data? That is where SQL comes into picture. So that is where the flow is. So that is why I've taken you through this entire history or entire pretext to all this entire this thing. Okay, so we know what data is, what are the different types of data, what is analytics, what are the different types of analytics, and what is the entire ecosystem. Now, in this, we saw as I gave you, we know that there is structured data. And this structured data, most of our business happens in structured format. There will be rows and columns. You go to a library, there will be registers. You go to a bank, you have a passbook. You download your bank transaction, it will be in rows and columns. You take a simple registration form, it will be in rows and columns, right? Everything, almost everything that we do is kind of in a structured format. And there are things which are unstructured also, but right now we know that there is structured data. And next thing that we are going to learn is, if there is structured data, how can we analyze it? Okay, so before we analyze it, if we have structured data, we need to store it somewhere, correct? The obvious choice of storing it is Excel sheet. Everyone has used Excel sheet or Google Sheets in one way or the other. Now, there's a limit to the data that you can store in Excel sheet, right? If it is a huge Excel file, you know that sometimes your Excel crashes, etc. Right? If it's like 10 million rows, or if it's like 100 million rows, your Excel can't handle it. So where do you store it? That is where the concept of relational databases comes into picture. Now, very simple. It's not a rocket science. Relational database is nothing. Imagine it as a hard disk, just like your hard disk, but where you can store data in an Excel format. Imagine an Excel with unlimited or with a huge storage capacity. That is what relational database is. Similarly, when you have multiple such Excels in your hard disk, that becomes a database. And if these Excels can be connected with each other, then it is called as a relational database. Okay, database is nothing but where a repository of data, which means nothing but where you can store your data. What does it help you to do? You can add more columns, add more rows, you can modify the value that is there, and you can try to fetch certain details from that. That is what is called as database. There are different kind of database to store data in different forms that are slightly advanced, but for the time being, just understand what database is. Okay, now what is relational database? When you store your data in a tabular form. What is tabular form? Rows and columns. When you store your data in rows and columns format, it falls into the category of relational database. RDBMS stands for nothing but Relational Database Management System. It is a software which manages your relational database. Okay, imagine RDBMS just like your Adobe Photoshop. What is your data there? It is nothing but your images. What does Adobe Photoshop help you to do? It helps you to manage your picture, modify the picture, edit the picture, right? Store the picture, add more pictures into it, etc. Crop, etc. So it's a software that helps you to do all these things, right? Manage it. Same is the scenario with RDBMS. When you have data in rows and columns, and when a software that helps you to manage it, store it, modify it, query it, that is called as RDBMS. RDBMS stands for Relational Database Management System. Okay, it's nothing but a set of software tools that controls the data, access the data, organizing the data, and the storage. All with me now, till now. Any questions? Any questions?
There was one question regarding the difference between big data and normal data.
Great. So it's a different topic, but then I'll answer that. Okay. Now, big data, everyone has a confusion with what big data and normal data is. Big data is same as your data. Okay. Big data is again nothing but your data, but when it has certain characteristics, you call it as big data. So raw facts and figures, which is your data, when this data has certain characteristics, you call it as big data. Now, what are these characteristics? Theoretically, when big data came into picture, there were only three characteristics. And you might have seen it everywhere. The three V's of big data: volume, velocity, and variety. Okay. If your data is of huge volume, if your data has different variety, and if your data is generated in a high velocity, then it is called as big data. Again, it's nothing but data itself. Okay. When data is of huge volume, it is generated in high velocity, and if it has different variety. What is different variety? Structured, unstructured, and semi-structured. If your data has all these three, or at least two of them, if these three characteristics are satisfied, then you call that data as big data. As and when industry started taking big data into their organization, more V's got added. Okay, like value, that there is veracity, etc. And so now I think there are 9 V's, but theoretically, when it came into picture, there were only 3 V's, and you should remember at least these 3 V's: volume. And what is the volume? It should be high volume, huge volume. Velocity, it should be produced in a high velocity. What is variety? Different varieties, which is structured, unstructured, and semi-structured. A simple example for that is your Facebook data. Okay. Right now, most of you might not be posting anything in Facebook, but someone else is posting, right? Which means that there is continuous generation of data. There is high velocity of data generation. Everyone is posting out there, millions are posting. There is huge volume of data, right? And there is different varieties. Some of them might be posting text, some of them might be posting videos, some of them might be posting pictures. So different variety. That is what big data is. Again, bottom line, big data is nothing but data itself. But when data falls in the, or when data follows these three characteristics, it is called as big data. All good? Big data question. Whoever who asked, I think I have answered your question. Okay. All right. Now we're coming back to the topic. Database, repository of data, provides the functionality to add, modify, etc. And the software that manages it is called as the RDBMS. Now, there are different types of relational databases. There are commercial relational database, which means that a company creates it and company sells it. For example, Oracle has an Oracle database. Microsoft has something called as SQL Server. IBM has something called as DB2, etc. Then there is open source relational database, which is the software is managed by Apache. It is open source. You, for your personal use, you can use it for free. But when it comes to commercial purpose, you will have to pay the license fee to Apache. A few of the open source relational databases are MySQL, PostgreSQL, SQLite, etc. Now, if you are confused, there are other cloud databases which are like Amazon Dynamics. Now, if you're confused what all this means, imagine you have different softwares to edit your picture, right? It could be a Photoshop, or it could be something else. It could be a simple app in your phone, etc. Everything does the same, editing your picture, enhancing it, correct? But these are different softwares. They do the same thing. They have different functionalities. They have different capabilities, but the underlying idea or the work is the same: edit your picture. Same is the case. You have different databases, different softwares, which helps you to store the data. One might do it in one way, one might do it in another way. One might have extra capacities and capabilities where other one doesn't have that, etc. So these are different softwares that help you to manage your relational data. Okay, so different databases or different names that you hear are nothing but different softwares and different repositories provided by different organizations. Okay, that's all. Now, next one. What is SQL? Okay, SQL is commonly pronounced as SQL. SQL. You know that there is structured data. You know that it can be stored in your relational database. Now, there is one point which I had told that you can, let me go back to that slide. There is a functionality of adding, modifying, and querying the data. What do you mean by querying? Querying means trying to fetch information out of the data. How do I do that? For that, so when let's say that me and you are interacting, how do I get information out of it? I speak a language that is common to both of us. I'm talking to you in English and I ask you questions, I get answer, right? There is a language that is helping us to interact between us, and then you ask me a question, I give you an answer. I ask you a question, you give me the answer, and then we exchange information, right? So there is a language that helps us to do it. Similarly, when you have structured data and you want to ask question to that structured data, you use SQL. And now it is easy to understand. Structured query language, a language that helps you to query the structured data. That is what SQL stands for, structured query language. Okay? All with me? SQL stands for structured query language. It helps you to query the structured data. Okay. Where is your structured data stored? In your relational database. Languages used for relational. Yes. Now, there are different types of SQL statements. Okay. One is called as DDL. DDL is called as data definition language statement. It is used to define, change, or drop the data. Okay, certain commands which helps you to tell how a table should look like. What are the columns that should be there in the table? How many columns should be there? What is the value? What are the types of value that you can store in a particular column? All this is used, but all this is defined in a set of statements called as the DDL. DDL stands for data definition language. Next one. So the few of the DDLs are create statement, alter statement, truncate, drop, etc. Okay. Create is used to create a table. Alter is used to alter the table. Truncate is used to delete the data that is there in your table. Drop is used to drop that table. Okay. Table is nothing but the things that you create. Table just looks like an Excel where you have rows and columns. Okay. If you want to create a table, you use the create statement. If you want to change the number of columns or something in that, you use the alter. If you want to remove all the rows that you have stored in a table, you use truncate. If you want to remove that table altogether, you use the drop. All these comes under something called as DDL. Next one is the DML, which stands for data manipulation language. This is the statements that you use to ask the DBMS and fetch answers from it. Insert is where you insert a new row. Select reads the data and gives you information about it. Then there is update where you can go and update a value. Okay. Then there is delete, which delete a row. Okay. So two types of SQL statements. You know what SQL is. SQL, the full form, structured query language, a language which helps you to query the structured data. Two types of SQL statements, DDL and DML. DDL related to the definition, data definition language, how a table should look. Can I alter it? Can I create it, truncate it, drop it, etc. At a table level, DDL. For the data that is there in the table, to insert new records, to select a record, to update a record, to delete a record, you have DML, data manipulation language. Let's move to some of the select statements. If you want to see that how many rows are there in your data, you use the count function. If you want to see how many distinct unique values are there in a particular column, you have distinct function. If you just want to see only the first 10 rows or 20 rows, you have a function called as limit. If you want to look for data which satisfies certain condition, for example, there is a database which has information about people staying in different locations, and you want to see only the information about people staying in Delhi, then you tell that I want to see, select the information about people where location is Delhi. So this where condition helps you to put filters in your query, and then it gives you data set corresponding to that conditions that you're there. If you want to select people with the name starting with Rohit, you will put like Rohit. If you want to check whether, if you want to pull data of people whose age is between 20 to 50, you use the between and operator. Greater than or equal to 50 and less than or equal to 20. So between and, if you have multiple where conditions, I want to check whether this particular person is in Bangalore as well as his age is this much, you use and where location is equal to Bangalore and age is age between 30 and 50. If you want to check only one of these conditions, either the person should be in Bangalore or his age should be greater than 20, then you use or function instead of and. In and, both the conditions or all the conditions should be satisfied. In or, one of the condition only needs to be satisfied. In means, if you want to check into a list, for example, I want to see the people who are both in who are either in Bangalore or Delhi. So what you give is where location in Delhi, comma Bangalore. In if their location is either in Delhi or in Bangalore, show me that. So in is used. Order is if you want to fetch the data and see it in a particular order. Order all the people in increasing order of their age. You use the order by age ascending, order by age descending. If you want to group the people based on their location, tell that, okay, group everyone from Bangalore together, group everyone from Delhi together, you use the group by function. And then on top of the group by, let's say that you want to see, I want to group all the people from Bangalore and see who has age more than this much, then you use the having function. Group by the data and then having this certain condition, use it. So these are different select statements that you run against the database to fetch the data, to query the data, to see the data. Okay. Now, moving on, there are other certain built-in functions in SQL, which is if there is a column and you want to see the sum of that entire column. In Excel, you can see it at the bottom. Similarly, in SQL, there is a function called as sum. If you want to see the minimum value, maximum value, average value, if there is a column which has a text in it, which has your name, and you want to see what is the number of characters in it, you use length. If there is a number and you want to round it, you use round. If there is small letters, capital letters, if you want to make it to uppercase, you use either the upper function or case. If you want to make everything to lowercase, you use lower. If you want to get the date out of a string, you use the date function, time, date, time, timestamp, etc. So these are certain built-in functions which helps you to easily fetch correct details out of it. Okay, so basic select statements, you can do count, distinct, limit, where, like, etc. And certain built-in functions where you can do aggregations like sum, min, max, average, etc. Okay. Now, there is another concept of sets. You might have learned it in your 11th, 12th. I know it's a bit towards yesteryears, but then union, when you have two data set and you want to union them one after the other, you use the union function. If you want to see only the rows that are common to two data set, you use the intersect. If you want to see all the records of a particular data set, but which is not there in another data set, you use except. If you want to see in union, when you combine two data set, if there are duplicates, it will show only one of that. It will neglect the duplicates and show only one. If you want to see the duplicates as well, you use union all. Then comes something called as the join, which means nothing but table. There are two data set, table 1, table 2. If you want to see what are the elements that are common to table 1 and table 2, you use inner join. If you want to see the data that is common to table 2 and that is there only in table 1, you use left join. The ulta is right join. And if you want to see all those that are there in table 1 and table 2 together, including the intersecting, we use full outer join. Okay, so understand that there is concept of set, join, etc. It will take much more time to go into the details and understand how this can be written. But if you can remember this picture, this will make it easier. Join, inner join means where is this common portion? Left join means common portion plus left part of the data. Right join means common portion plus the right part of the data. Full outer join means complete data. Okay. Now, next is the data science, AI, and ML. So now we know that we have learned about what is data, structured data, unstructured data, analytics. Why are we doing? What is SQL? What is data repository? What is relational database, etc. Now let's try to understand where does this fit in your data science and AI ML. So before that, let's try to understand what all this means. So if you see here, your data science is the base of it. Data science is where you do all these statistical tests, you try to understand, you try to do the analytics, etc. Okay. From there, you come into something called as deep learning. Deep learning is nothing but a subset of machine learning where you use something called as the neural networks. Okay. Neural networks are a totally different concept altogether, but understand that don't get confused when people say I have learned deep learning, etc. Deep learning is nothing but a part of machine learning. Now, what is machine learning? It is again a part of AI. It basically uses the statistical methods to enable machines to predict, enable machines to understand the patterns, etc. That is what ML is. So your AI is where machines try to mimic human behavior. Okay, so you might have all used ChatGPT. It's nothing but generative AI. What is that? You talk with ChatGPT as if you're talking with a human. It's trying to act like a human, correct? That is what AI is. If it is mimicking a human behavior, that is called as AI. How can AI be enabled? Using machine learning. And one of the technique in that machine learning is deep learning. All these uses data science. What is data science? Data science is where you use maths, statistics, visualizations, EDA, exploratory data analysis, etc. So this is how the entire ecosystem looks like. So your data science, from there you come to machine learning, and from there you come to artificial intelligence. So a subset of AI is your ML, a subset of ML is your data science. Now, in order to do this, one type of data is structured data, correct? Structured data can be analyzed using SQL. So data science, for data science, AI and ML, one of the important type of data is structured data. And to analyze structured data or to achieve AI or to do machine learning, you need to analyze your structured data. For that, you can use either your SQL or your Python to do it. Okay. And SQL is what we saw as structured query language. Now, Python, you might have all heard about it, learned about it. So I'm not going to give much details about it. A few good characteristics about Python is here. It is easy to learn. There is a lot of Python libraries and it becomes easy to use that. Okay, some of the common libraries are your scikit-learn, Keras, TensorFlow, etc. These are all details. Now, how does SQL support in Python? The Python programming language has features that helps you to write SQL in it, which will hit a relational database and fetch your data for you. Now, what is the importance of this? If you see almost your 90% of a code now, okay, now in the current world, almost 90% of the code is written in Python. And one of the data type that is used for that is your structured data. And your structured data understands, if it is stored in relational database, understands only SQL. So Python should have a capability to fire a SQL query against a database. Now, imagine it as if you have a translator who helps you to translate your language to another language so that you can communicate. This is what it means. Okay, so Python supports SQL in it. Okay, Python supports SQL in it, and so this SQL is which helps you to query the language in relational database. Okay, and so this Python is used to create your ML models, your AI, etc. So the entire picture is, I'll give you the entire picture. You have data, right? And this data, there are multiple types of data. You need to analyze this data to build machine learning models so that your AI is enabled. Now, one of the type of data that you have is structured data. So you need to analyze structured data also. The structured data is stored in your relational database. The relational database understands only SQL. Your Python code helps you to build machine learning models. And so your Python code will have an SQL support, which will connect to the relational database, manipulates your relational data or your structured data and utilize it in your ML models. This is how the entire picture will look. Now, being all said this, what is important is you should know how to work through a problem from beginning to end. What does that mean is there is a specific format to solving your problem, and you should know how to solve that problem. All your technical knowledge, all your business knowledge are all good, but there is a process to follow to it. What is that? The first one is you should understand what the business needs. Remember the example where I said that you have two routes and I have to reach the destination. What was the business needing is the important question, and based on that really you will do the data analysis. If I had to reach early, then my solution is different. If I have to reach at a cheaper cost, then my solution is different. So always start with understanding what your business needs. Then you should understand what is your data. Is it structured, semi-structured, or unstructured? How do I analyze it, etc. First, understand what the business needs. Then you understand what your data is. Then you use SQL for data science to analyze the structure. If it is structured data, you use SQL built inside Python or something to analyze it, etc. And last one, usually all your data science projects will be centered around a problem. Okay, and that question is what you are trying to solve. How can I improve my business? How can I reach early? How can I reach at a lesser cost? There will be a question always, and you are trying to solve that question. And for that, you first need to understand what that question is. How does it help the business? For that, what is the data that I need? What is the data that I have? How should I analyze it? Whether it's structured data, then I should use SQL. If I have to build machine learning models, I have to use Python, etc. This is the important piece of it. You should know how to solve the problem from beginning to end. What is the beginning? Understand your business, understand your data, figure out how to solve that problem, figure out what will be the answer that you have to give to the final question. Okay. Now the next steps is, since we only have like 45 minutes to 1 hour, after this, how can you proceed further with this learning is, there are topics like subqueries, which is nothing but different types of subqueries. You can learn about that, which will help you to improve how fetching your data from relational database. So there are some of them that I've listed down here. Then there is something called as regular expressions. Then there is something called as the window functions. So all these are advanced level in your SQL, where you can write queries and then try to fetch data. You can try to analyze your data. You can try to manipulate data. So these are the next steps, advanced level. Okay. So just to wrap up before I enter into Q&A, I'll just have a revision of highlights of what we learned in this 45 to 60 minutes, which is, we understood what data is. Data is nothing but raw facts and figures. When you process it, you get information out of it. And you saw an example, which I hope you all understood what is the difference between data and information. Okay. From there, you understood what are the different types of data: structured data, semi-structured data, unstructured data. Then you went and understood what is data analytics, what are the 4 types of data analytics, what is the order to it: descriptive, diagnostic, predictive, and prescriptive. Now you know what is data, what is analytics. And if there is analytics involved, there will be structured data. And if you have structured data, you need a relational database to store it. So that is what, in order to manage that relational database, you have RDBMS. RDBMS only understands SQL. SQL stands for structured query language. SQL has different types of commands, the DDL commands and the DML commands, select statements and built-in functions. Then there is this advanced level. Now, where does this sit in the current industry? There is a lot of push for AI. There is a lot of push for ML, machine learning, etc. All this comes from data. All this comes from data science, right? So if data is there, there will be structured data. If structured data is there, you need to know SQL. Only then you can use that data for your machine learning models, which acts as the base for your AI. That's the whole picture to it. And then I give you the next steps on what should you learn so that you become more advanced in SQL. All right. I know that I went through a lot of topics. It might be a bit overwhelming, but unless and until I give this entire picture, it will not give any sense to it. You should know why you are learning it, what is the importance of this, etc. Right? Then only it makes sense to it. That's why I have to give you all this, but I don't think I've gone in too much technical to bore you out. Okay. Now let's take, could you show the previous screen? Yes, Abdul, this is what it is. Okay, this is more towards technical side of it. Okay. There are certain functions like rank, lead, lag, first value, last value. I'll give you a simple example. Rank is, let's say that you have each of the row based on the marks. Let's say that to see who got most marks. If you want to write
Mary, I think there is
a SQL statement, these are the next steps. Yeah.
Yeah, I think there was a voice lag. It's fine. Yeah.
Cool. Sorry. Yeah.
So I'll just go to the scroll to the top. So off topic.
Next, how to make a career with free. Is it
I think there's a lot of lag now, voice lag, and you're able to hear us after quite a lag.
It's just gone down. Okay, how is it now? Is it coming out right?
Yeah, it's better. It's better. I think you can keep the video off. I think it's fine.
Yes. So one of the question is how to make career with free resources and get jobs in this career. There are a lot of free resources. See, it eventually boils down to how you utilize it. You can get, I've seen people getting certificates for the sake of certificate to show it off in LinkedIn. That whatever that you're going to do, you have to understand, you have to learn.
Maybe there is a voice.
Okay. So there are a lot of free resources out there. YouTube videos, Academy, Coursera also provide certain.
Guys, meanwhile, when Mary connects, I'm just sharing the feedback form for the session on the chat box. Please try to fill in the feedback form, which will help us improve on the next sessions. And I'm also sharing the Apna Exclusives link where you will find the recordings and details of the upcoming sessions. You can register for yourself and access the recordings and find the details of next sessions as well. We'll just wait for a couple of minutes until Mary reconnects. Yeah, Mary's here.
Is it better now?
It's better now, Mary. If you want, you can keep your video off. It's fine.
I'll do that. I don't know. Yeah. Cool.
Yeah.
So let me post. Can you just give me the okay? It's going to be Q&A, so I don't have to share much. So
Yeah.
the question was, how can I use free resources and then get a job in this career? Yes, there is a lot of free resources, but the only thing is utilize it for this for your benefit. You have to understand it in detail. Don't just do it for the sake of completing a certificate. I've seen many people doing that. Learn it, and then it doesn't happen overnight. You have to spend time for it. Everyone, I've seen this trend that is happening among a lot of youngsters now. They want to take things very quick within like two hours. If they can complete the entire data science concept, they're happy. No, it doesn't happen like that. You have to give in some effort, you have to give in some time, you have to be patient about that. Okay, so learn and consistency is something. There should be a consistent pattern to your learning, and that will help you. Okay, next question.
And is it possible to get into the data field with just skills and not having a formal degree?
Yes. See, it's like how should I put it? It's like a chicken and egg problem. Okay. Now, you do not know which one should come first. So I've seen certain organizations asking for experience and then all these things, but there are certain organizations I'll talk about my organization. We have both types of requirements. One where we look into people who knows this stuff, and there are certain criteria that the HR keep in, where we have to go to certain colleges or universities and pick the students. So there are organizations which sticks to only certain criteria, like I'll go to this particular university, or if you have a degree only, then I'll take. And there are universities like there are organizations where they just look into whether you know this stuff or not. Okay. And one simple example is mine, where I was into data engineering background, and then seeing my skill set, my data science manager gave me an opportunity, and I moved into data science field. And then I felt the need. I felt like I should, anyway, I'm going to understand more about data science and then do more work in data science. So I then took up the data science masters. So initially the opportunity came to me. So that was purely because I was interested in data science. I started reading about it, etc. And then that's how that opportunity came. So for your question, am I breaking?
No, you're fine.
No, right? I hope I'm not breaking in between.
No, you're fine.
So the simple answer to that question is, yes, you do have opportunity there. The skills taken to answer, but for the first part, I can give you straightforward answer, which is you will not be able to get into or survive in data analyst field with just only Power BI knowledge. Only Power BI knowledge will not help you to survive in the data analyst field. Power BI knowledge is one that will help you in moving through, but not only that. Okay, you need to learn SQL, you need to learn Excel, etc. Okay, higher package, dude. I have no answer for that. It depends on you. How well you showcase your skills, etc. is what. See, what you have to understand is, just by letting people know that you know a tool will not help you to get higher package. It might 90% or 95%. It's not like that. You have to make them understand that you know the skill. Okay. And there are a lot of people who know multiple stuffs now. They know Excel, they know Power BI, they know Tableau. So the more you know, the better. Okay. And then if you see, Power BI is very much similar to Tableau. So if you know Power BI, industry knows that, okay, you know Power BI, which means that you will be easily able to adapt to Tableau. So knowing one kind of a tool helps you, but there are multiple skills that you should possess. Okay. Any other questions which I missed, Rohan?
No, I think you are good. I think we are.
I'll take one more question, maybe last one question, if there is any. I know that we are like 15 minutes overboard, but if any other questions, if not, you can connect with me. So I'm there in LinkedIn. You can connect with me and then send a ping and then ask for anything that you have queries for. I'll be more than happy to help you out. Again, can I crack a job with only Power BI? I think I have answered that, Argajit. I don't think just with Power BI it's going to work out. You need to know more skills for data analysts. Okay. See, Python is a very common thing that everyone is using for data analysis. SQL is another one. Excel is another one. So Power BI alone, Power BI is more towards reporting, if you see, rather than data analysis. It's more towards reporting. Okay. Data analyst is more towards analyzing what your data is, etc. So no, simple plain answer is no. You may be able to crack a job, but in the long run, it will be tough for you to survive there. All right. So, can you give a proper advice, like do this course and then do this? It depends on what you are trying to learn. Okay. So, for example, I just saw someone coming and looking into the mobile and then just walking away. Sorry, it got distracted. What do you want to become? Is it a data analyst or a data scientist? If it's a data analyst, your step is different. If you're a data scientist, your step is different. If you want to become a data engineer, your step is different. If you want to become a data analyst, the simple way is understand what data is, understand Excel, understand SQL, understand advanced level of SQL, understand a reporting tool that will help you with data analyst. Okay. And then next one is, if you're trying to become a data scientist, very simple, you need to understand data, a bit of data engineering skills, a bit of data analysis skills, a lot of statistical skills, etc. If you want to become a business analyst, you should understand how to make sense of business terms. For example, if someone comes to you and tell you that my company's revenue is this much, my company's COGS is this much, you should know what COGS means. COGS stands for your goods and service, cost on goods and services. Revenue is this much. AOV stands for annualized order value, etc. So you need to understand all these business terms. That's how you will get to become a business analyst. If I want to become a data analyst, what will be my roadmap in 2 months? Argajit, again, back to my answer, be patient. See, 2 months is very less time. I know that everyone is looking around for job, but trust me, the more time you spend is when you become a master to it. There is a reason why your master's degree are 2 years, your PhD is 8 degrees, because it takes time. Okay. Now, if you want to become a data analyst, in 2 months, first learn about SQL, second learn about Excel, third about any reporting tool. You already know Power BI, so you can skip that. I know I have knowledge about advanced. Very good. So move to SQL. Okay. Can you suggest how to connect with professional and ask question without disturbing them? Wow, depends. It's very much personal. For me, someone asking me a question, I'm more than happy to help. It doesn't mean that you can ping everyone and ask it. It's very personal question, Prashant. You can't generalize that. I'm sorry for that. There's no answer to it. You ping someone, it depends on their mood on that day to answer or not. So it's very much personal. Try sending a connection request in LinkedIn. If they accept it, it means that they're ready to have a conversation with you, and then start slowly. If they don't accept it, that's a clear cut telling you that I don't know you, I'm not going to interact with you. So send a request. That's the best way. Create an account in LinkedIn and try to connect with them. Again, Prashant, the bottom line is it depends on each person to each person. So great. I think I don't want, if there are no, I hope there are no other questions.
Yeah, there are no more questions, but if there are questions, we can surely take it up on email. We have overshot the time by 20 minutes, but it's completely fine. It was a very engaging session, Mary. Thank you so much for spending time and taking us through the basics and teaching to us like beginners. So it was really engaging and very interesting session. I hope people have enjoyed. I've sent the feedback links multiple times on the chat box. People, if you think the session was great, please feel free to get into the link and give us the feedback. And also we have sent the Apna Exclusives link where you will find the link of recorded sessions and any details on upcoming sessions. So thank you again. Thank you so much, guys. Thank you so much, Mary. Thank you, Dipanjan. Have a great day, great evening. Bye-bye.
Great evening to all. Bye. Bye.
Thank you, Melissa. Thank you so much.